Hello, everyone. A very warm welcome to all of you to this session on understanding applications of GIS. We will be talking about our latest study that is called Making Delhi Heat Resilient. My name is Mitashi Singh, and I work with the Center for Science and Environment as a program manager with the Sustainable Habitat program here. So I will begin my presentation. As all of you know, or many of you might know, that India is facing a severe heat spell. Since many years, especially since 2024, we have never seen summers as intense as this one. So, there was slight relief in the year 2025, but again in 2026, the problem is quite fierce, and we have recorded many deaths in a day due to India's extreme heat. And it's not only Delhi, but major cities of India, such as Mumbai, Chennai, Bangalore, Kolkata, and other northwestern states are facing this problem. Urban areas, especially, are facing quite intense problem of heat. So these are some news bites from several media houses that tell us how heat is not only causing an impact on public health, but it's actually uh, causing problems like vehicles catching fire or air conditioners catching fire and so on. So we have never anticipated this kind of an impact of rising temperatures. So as for temperatures, if we take a look at Delhi, so we certainly have a new normal here, because as you can see, if we look at the summer months that are basically from March to July, it continues until August and September, but these are harsh months. So we can see that out of 50 occasions, we are departing from the normal temperature on 42 occasions. So you see that Delhi is not seeing any normal temperature summer anymore. Also, it's not only about the daytime temperature or maximum temperature, but the nights are also not cooling. So the city, not just Delhi, but many other cities such as Mumbai, Kolkata, Hyderabad, Bengaluru, and Chennai. So we conducted an analysis over 2 to 3 decades, and we found that our cities are not cooling down as they used to be before 2010. So overall, we have noticed a 9% reduction in diurnal cooling in Delhi. This means that the difference between the maximum and minimum temperatures in the city, that used to be roughly 12.3 degrees Celsius in the decade of 2001, has reduced to 9.8 degrees Celsius. So the problem continues in the night. It's not only a day problem. Now, when the cities are heating up, it's not impacting different people in a uniform manner. So you see, there are populations like the construction workers, street vendors, elderly, women, children, those who live in the informal settlements, and homeless people. These populations have it much worse than people like us do, because these people, they basically do not have any good means to cool themselves. For instance, electricity. Some might not even have access to safe water. Forget air conditioning. Many might not even own a fan. And second problem is that many of these groups have to be out there in scorching heat to earn a daily wage. For example, street vendors, if they don't sell, let's say, fruits or vegetables throughout the day, they will not have any money to take home and earn their bread and butter. So, this is a matter of vulnerability, much more here in the cities. Now, to break down this vulnerability, we prepared a methodology. So I'll share that with you. So, first of all, we wanted to understand what is the exposure, what is the level of heat that is facing Delhi currently. So, for that, we found out a few indicators, such as which are the areas that have very high LST. Now, you might be wondering why we have worked out with the land surface temperatures and not the real time temperature, or not why not the air temperature. So the thing is that we have very limited observatories across the city. So as you know, that the temperature can vary widely across a single street. It depends on what part is shaded, what part is exposed, what are the activities that are going around, that are happening on that street. So all these factors contribute. So in that case, if we want good data, satellite data becomes a very good source of telling us, it becomes a good pseudo indicator of telling us the problem of heat. So if you want to do a temporal assessment, that is assessment across the years, if you want to understand how the temperatures have shifted over decades, one way is to conduct climate modeling. But as you know, that process is very expensive. Climate data is very expensive. Weather data is very expensive. And to conduct and to prepare a climate model, it again requires roughly 5 to 10 years. So, satellite information such as land surface temperature becomes very handy to deal with this subject. We then we use that. We also identified the area that does not have any green cover. When I say green cover, it includes trees, shrubs, and even grass. And we also found out which area does not have any water body influence. As you know, as many of you might know, that Delhi has a river, Yamuna, passing through, and there are also some canals. So these water bodies have a good influence on mitigating the heat. So we have to eliminate that when we are trying to establish the exposure to heat for the people. So this gives the overall exposure. Then when we overlay that exposure, that exposed land, I must say, with different vulnerable groups such as street vendors and construction workers, which are basically vulnerable due to their occupation. So it's an occupation related vulnerability. For age related vulnerability, we have children and elderly. Children, especially those who are younger than 10 years, and those who are aged above 60 years fall into this category. Then gender-based vulnerability, that is for women, because you see women have a very different thermoregulation as compared to males. Women sweat less, so they are able to thermoregulate their body slightly less as compared to males. So this makes them vulnerable. And then there are other hormonal factors that add to the problem. Housing condition, how people are living in this heat, what are the conditions of their house makes them vulnerable. If the house, let's say, comprises of tin sheets or makeshift material that are generally found in informal settlements, it certainly makes the occupants of that dwelling vulnerable to heat. Then homeless population, they don't have any dwelling at all, so they're constantly outdoors. They might even not get enough shade, so they're constantly exposed to heat, not only during the day but also in the night. Now when we combine these two uh, sections, what we get is basically what kind of short-term measures are required so that these vulnerable groups do not face uh, loss of livelihood, or it does not, the heat does not impact their health and other health related expenditures. So basically emergency measures, how we can safeguard these vulnerable populations and prevent any damage to health or property. Then third is the long term measure. As we know that the cities are now constantly heating up, this means that there will be higher temperatures, even higher than what we're facing now. And as we grow, as the cities grow, more people come to the city. Cities are going to trap even more heat. So, as you might know about the urban heat island effect, cities might trap even more heat. Now, if this is the reality, then cities definitely have to take steps so that they are able to release this heat. So one is the heat that is, coming to the cities because of climate change, and second is that the cities themselves are not able to release that heat because of the way they are built. So that requires certain long-term measures. Now, in this map, you will see this map is prepared using GIS. We have the boundary of the National Capital Territory of Delhi, and we have the different wards of Delhi. Delhi has some 270 plus wards, and uh, we have areas that show higher land surface temperatures, higher than 45 degrees Celsius. So this is a benchmark, or this is a threshold that we picked up to determine which areas might be having it worse, which areas might be facing the problem of heat slightly more than other areas in the same city. So if you're near a water body, if you're near a dense green cover, then you certainly might be facing the heat a little lesser as compared to the other areas that are completely, concretized. So, 45 degrees Celsius is the threshold that we chose for our work, and that gave us that 75% of Delhi's areas actually heat stressed. And if you ask me what kind of areas are falling under this heat stressed uh, coverage, this includes commercial areas, institutional complexes, industrial areas, then high density, low rise residential colonies, and some unplanned, self constructed colonies. So, in Delhi, here, the problem is that the population is growing at a much faster rate uh, when you compare it with the pace of development. So people are sort of compelled to buy their own land and construct their own housing. Now, they don't have adequate knowledge and also resources to construct their houses in a proper manner. So it's mostly unplanned or unregulated self construction that is happening all across the periphery of Delhi. And which is why you can see that the peripheral area of the city is more heat stressed as compared to the central areas. Just to show what kind of satellite images are there when we talk about these areas. So, for example, you see in industrial areas, it's mostly these blue roofs that you see. These are the sheet materials. These are the polyfiber materials that are usually used in industries. And in the bottom left image, you can see that this is how unplanned self construction looks like. So here, uh, we have small plots that are actually delineated by a colonizer. And when I say colonizer, I mean a local contractor or a local developer who buys a big chunk of land and then does the plotting themselves. And then they sell off the plots one by one to homeowners. Homeowners buy these lands, and this plotting is many cases is not regulated by the municipal body. So this is why we're calling it unplanned or quasi-planned self-construction. Then there's the old city core. So you know about old city of Delhi. That is also the walled city of Delhi. That is there since the time of the Mughal Empire. There, the settlements are quite packed, and also there is not much greenery. I would say there is no greenery at all. So, Old City Core becomes another heat stressed area. On the contrast, the new city core, which was supposed to be green and balanced and planned, on the bottom right corner, what you're seeing is the Connaught Place area of Delhi. That is the new city core that was developed by that was developed during the colonial period by the Britishers. And as you can see here, what looks green and well planned is again a heat stressed area. Now, why is that? Because it's not just the greenery that it's not just the density that's not playing in favor of the new city core, but it's also the density of roads and paved surfaces. So there are a lot of open parking spaces in the new city core, and the traffic volume, the vehicles that ply in this area is also quite high. Now, when that happens, anthropogenic heat load actually counters any impact of the greenery that is there in this area. Then we have some redevelopment projects. For example, the one on the top right corner. This is the Bharat Mandapam complex. That is our international symposium of a kind, you can call it, that was recently constructed by the CPWD. Now, the problem is that the greenery here is quite less, and the material and the surfaces are all heat trapping. Um, so, this makes this redevelopment project, this multi-million dollars of investment, also a heat trapper. So, this is how we have to think about, we have to look for ways by which we can reduce the heat trapping component in our new constructions. Now, how did we get here? So I'll show you some GIS related data sources and also methods, from where you can harvest data, because we talked about satellite data, and how you can use that data and get your own analysis done, get your own findings. So, first of all, we have to understand what kind of satellites are there. So, as you know, that there are many satellites, man-made satellites that are orbiting the Earth. So, that satellite travels at a fixed speed in a fixed orbit, and it repeatedly passes over the same location. Now, when sun's energy falls on the surface of the Earth, whatever energy comes back after being absorbed by the surface, whatever energy is reflected back is captured by the satellite's sensors. And when that data is trapped, then it is transmitted to a ground station, and we use this data and process it into information. So, speaking of satellites, different satellites, there are some 4, 5 satellites that are widely used across the world, primarily because of their resolution. Now, resolution is what one pixel will cover for you, the area on the ground, uh, whatever area will fall under that pixel becomes a resolution. So, for example, Landsat satellite, Landsat 8-9 is the latest version. So, it has optical and thermal sensors, which means it can measure visible light, near infrared, then thermal infrared spectrum, and shortwave infrared spectrum. And the resolution of Landsat 8-9 is 30 meters. How we can use this information is we can certainly find out the land surface temperature from the satellite, and we can also understand what is the land cover of a particular area. When I say land cover, it can tell us what kind of vegetation is there, what kind of water body footprint is there, and what kind of land, as in barren land or otherwise, is present. Then there is Sentinel, there is MODIS, there is EcoStress, there is SRTM. So you can see here how different satellites have different kinds of sensors, which helps them capture different data. So then there is this platform, NASA's platform, Appears. It's application for extracting and exploring analysis-ready samples. Now, this is a free tool. You can register here, and you can drop your GIS shapefile. Let's say you have a city's boundary. You can simply drag and drop that city's boundary here. So this application will help you place your city's boundary into their database. Now, you have the option of finding out different information about that specific boundary. For instance, relative humidity, surface temperature, and elevation, terrain, etc. And you can also do this temporally. So you have to enter a start date and you have to enter an end date. So this will help you conduct any temporal analysis. So I have an example here. For example, if you have to find out land surface temperature of a certain area, so for that, you have to give in the time period. Here I have given um, 1st May 2026 to 30th June 2026. So I'm picking May and June because these are two hottest months here in India. So I have looked at all data set, but if I am extracting land surface temperatures, which this means that I have to get rid of the cloud cover because that is going to hamper my temperature, my thermal data readings. So I have to keep satellite data of the images only where the cloud cover range is very, very less. Otherwise, the data will not be useful for me. I have set it. I have also selected the product that I want to use. For instance, in this case, it's Landsat Collection 2 Level 2. So if I pick up Landsat 89 OLI and TIRS Collection 2 Level 2, it will give me the land surface temperature information that I need for my analysis, or basically what I have used in case of Delhi. Now, speaking of Landsat 89 satellite, it's a very good satellite and it records uh, thermal data. It has different bands. There are 11 bands. So if band 1 is ultra blue, then band 11 is thermal infrared. So the resolution is mostly 30 meters. So if you'll take a look at bands 10 and 11, it records surface temperature using its thermal infrared sensors. It can help you find out crop water use and cloud detection and active volcanoes. So since this data is collected by this satellite, I have harvested this data. I've also harvested data about vegetation. So there is something called normalized differential vegetation index. So I have used the same satellite's data and I've found out how much vegetation is there in Delhi. There is a process of doing this. You can find out this process in one of our publications. I'll share that at the end. And you can also find out the water body availability in your given city boundary. So there is the formula for calculating normalized differential water index. So all these three elements, all these three information are captured by Landsat imagery. And when we process it, so this is how it looks like. So we have seen how green and water body footprint has reduced in a decade. So in 2014, what was 26.6% has reduced to 15.15% in 2025. And if we are able to, if we overlay the land surface temperature or the heat stressed areas uh, that we have found out using the land surface temperature data of the Landsat satellite, if we overlay these green, blue, and the heat stress areas, we can even find out what kind of vegetation is actually getting heat stressed. This means the vegetation that is not uh, helping me in coping with heat. So like this, we can do many analysis. You can see how we can also show temporal variations in a map. So now if you look at the map in the right, the pink and light pink. So the dark pink is actually the hotspots. This is the areas that I've highlighted here that get heated up in the month of April itself. And light pink is the area that gets heat stressed until May. So I can show this month-wise variability also in the map. Because if we talk about heat stress, it's not only variable spatially, but it's also variable temporally. And we can show this temporal difference using GIS. Now, coming to the vulnerable populations, you see how we have been able to overlay different vulnerable groups information on this heat stressed map. What it has given us is the percentage of that vulnerable group that is living or working in heat stressed locations. So this gives us evidence for the heat emergency that we have been talking about. This gives us the evidence to act for, especially for these vulnerable groups. So we were able to extract some data on construction workers, where these sites are and where the workers are concentrated. We overlaid that, and here we found that 77% of the registered sites are actually located in heat stressed areas. Similarly, street vendors, we mapped all these markets. Actually, we used the mapping done by peer think tanks and other researchers, independent researchers. We overlaid that information here on GIS. So this is a point information that we have overlaid with our heat stress map. And we found out that 84% of the markets in Delhi are located in heat stressed area. Speaking of markets, there are more softwares that enable us to understand outdoor environment and how the microclimate is varying in that outdoor environment. So, let's say if we do something, for example, if we add some shading to a certain area, is that a good decision when it comes to safeguarding from heat or not? So these softwares can help us decide about that. So this image here shows the surface temperature as well as the air temperature in a 100 by 100-meter block in Connaught Place at 2 p.m. in the month of May. And as you can see, the surface temperature here goes as high as 60 degrees Celsius. Now, if we add some greenery or some artificial shading here, you can see that the software tells us that the microclimate will be improved by reducing surface temperatures by 20 degrees Celsius in some locations. Other locations, there are different temperature reductions like 18, 20, or 9 to 14, or 2.5 to 3 degrees Celsius. Uh, and so on. Ambient temperature reduction or air temperature reduction is 1 to 2 degrees Celsius. So this is another example of what cities are up to in India, how we are trying to regulate microclimate by using elements of shading. This is the platform where we have put up all this research conducted in different parts of India, also comprising different solutions. You can definitely take a look. And coming back to our vulnerable groups overlay on the heat stress maps, now we overlaid homeless population that was surveyed by another peer think tank. We overlaid informal settlements that were mapped by a government agency here, and you can see that 76% of those settlements are falling under heat stressed areas. Then schools become very important because schools are where spend children spend a lot of their time in the day. If those places are not safeguarded, we face the risk of students dropping out. So, temperature regulation, cooling devices, and safe water are a few things that we have to equip our schools with. So, we did one study here using GIS. We found out the rooftop surface area of these schools, and we calculated how much solar energy can these schools generate, how much uh, what potential these schools have to generate rooftop solar energy. So as you can see here, this mapping was not a point mapping that we conducted using GIS. This was a polygon. So we had the sites of these schools through OSM layers, and in GIS, we marked these polygons of schools. And after that, we were able to find out how much rooftop area these schools actually have. Unfortunately, 80% of these schools that we mapped lie in heat stressed locations. But the good news here is that these school rooftops can actually support 13.73 megawatt peak of solar power. So this such assessments also show us opportunities and how we can convert these into action later on. Then for women, children, elderly, we did the same thing. Now, because this was census information, and census information for Delhi was available at ward level, so we linked our ward boundaries with the data in Excel sheets, in Microsoft Excel sheets. And when we did that, this is how the mapping turned out to be. The dark ones are high population of that particular group, and the light one is the less population of that particular group. So you see how we can also highlight um, different spaces in the map when they're linked with data. Now, when we overlay all this information, presence of all these seven vulnerable groups, and also the problem that there are no vegetation, no water bodies, uh, and the land surface temperatures are constantly high across the decade. So, when we overlay all these things, we get a composite vulnerability map, and we're calling it a cumulative vulnerability index. So it gives us which ward has the highest vulnerability in terms of all problems. The temperatures are high, there is no blue and green element, the concentration of vulnerable groups is also high. So when we combine this, we get that there are four wards in Delhi. Wards are the smallest administration units that are governed by the urban local bodies in Delhi. So we have four wards that have a very high cumulative vulnerability. And such analysis tell us where to prioritize our actions. Also, what kind of actions can we take? Because when we took a closer look in these four wards, we saw that there are definitely no green or blue spaces here. There's high presence of quasi-planned self-constructed colonies. There are industries in some of these wards and also many informal settlements. So this tells us what kind of interventions should be coming and where they should be focused at. So this is the study here. You can use this QR to download, and you can give it a read, and you can then find out that we have developed two kinds of strategies. One is an emergency response that looks like this. So we're saying that don't consider the air temperature, but try to shift to heat index because it's more representative of the problem of heat. It also talks about relative humidity along with the temperature, and it gives you the real danger of heat that is there for humans. So we attach the risk level with it, and what actually should be the response for that heat index category. So this kind of a response system was created. And speaking of strategies, we worked on strategies like reducing workload, reducing duration of work, for instance, involving more breaks. If the construction workers, for instance, are getting one break in their entire shift of 8 hours, then give them two breaks. Or let's say if there are more women or there are elderly, give them three breaks perhaps. If there is somebody with a comorbidity, give them more breaks. Then we can also stagger work timings. So this is something that is already happening in Delhi under the heat action plan, that we are able to stagger the timing for, let's say, construction work. So the construction was happening early in the morning until noon, and then it was resuming 4 p.m. onwards. Then whichever activity can be moved indoors should move indoors. That is another strategy. Then working on cooling infrastructure is one of the strategies. Then we have to develop SOPs. India is in a strong need of developing standard operating procedures. For instance, what should be the heat emergency response? For instance, my organization, CSE. CSE should also know if there is the problem of heat, what should be the institution's response in terms of safeguarding its employees and especially protecting the ones who are vulnerable to heat. So, such standard operating procedures should be there. Frequent medical screening for the vulnerable groups, then some kind of fiscal support systems. So, there are uh, solutions like parametric heat insurance, implemented in India. So, in the city of Ahmedabad, women artisanal workers are given a certain amount of money the moment temperature crosses a certain threshold, such as 42 degrees Celsius or 43 degrees Celsius. They have paid a premium for it, roughly amounting to 200 or 300 rupees, and they get about 2000 rupees the moment temperature breaches the set threshold. So, this kind of uh, risk externalization systems in the form of parametric insurance are also emerging in our country. Then, certainly, there is a lot of awareness effort that is happening in the country. So you can see that these strategies are a mix of reducing exposure, mitigation, and also increasing adaptive capacity of the vulnerable groups. So as you will read, as you will go through the report, you will see how we have been able to use GIS and uh, inform our advocacy and direct our efforts into an area where we expect that there will be an implementation. So I'm happy to inform everybody that the Ministry of Housing and Urban Affairs has taken a good note of this study and has also launched a heat resilient cities project. So 12 cities have been selected under this, and these cities are expected to demonstrate cooling interventions in a year. So they have to implement certain pilots, certain cooling strategies, and show that these strategies have helped bring down temperatures or helped safeguard vulnerable populations to a good extent in this 1 year. So CSC is working with two cities closely on this aspect. So you see how, such analysis, such quick assessments that are supported by applications and softwares like GIS help the government make quick decisions like this one. So, with this, I will end the session. Thank you so much and have a good day.